Afcat Gk? वैसी वाली शेप निकल रहा है। गुड मॉर्निंग फ्रेंड्स। क्या? चलो छोड़ो तो। गेट क्लोज करना। गेट क्लोज करना। So good morning everyone. Today we are going to discuss the GK/GS for the FCAT, and previously I have covered the static part of uh, the questions and other organizations whatever there for the FCAT exams. So two three questions usually comes, and now then we have started our the science part. In science part, we have discussed two chapters in physics, that is units and measurement, and then work energy. So today we are going to discuss another chapters, that is the universal law of gravitation, force in force, universal law of gravitation. In this, what we see usually, the law of gravitation, there is always the gravity which we feels around in our solar system. The planets are the means they are their own elliptical paths rotating in their paths also. So there is some forces uh, giving each other. So they are at their right position. So the in this regarding this, the force which they are getting, that is the force between two masses, like this is mass one, and in another case this is mass. They are apart from the mass two, and this is the distance between them are. Now the force will be. is directly proportional to product of two masses and inversely proportional to square of distance. So it's the force force will be we write as k constant to upon r square. This is the force which we find between two bodies, and here we write it is we usually we denote with the g. It is gravitational constant g. Of this gravitational constant. So now we can discuss another force, that is electrostatic force. We are going to discuss another, that is electrostatic. In electrostatic force, what we find it is it is between two charges, charge two. Distance is r. In this case, the force is equal to directly proportional to product between two charges and inversely proportional to distance between them. So the force is equal to k constant q1 upon q into q2 upon r square. So this value of k is we write it as 1 by 4 pi epsilon. This we write as a value of k. In this case, the in this case from gravitational constant, the value of gravitational constant is value of g is equal to 6.67 into 10 raised to power minus 11 Newton meter. Meter is will go there and it will be square in form above, and the upon kg square, it is like that. And the SI unit, this is we call it as its SI unit. This is will be its SI unit for gravitational constant. And this has been discovered by one thing discovered by the this is discovered by Henry, scientist Henry Cavendish in 1798. In case of the electrostatic force, the uh, SI unit is coulomb. And, and the one thing which is there between them is between both the common thing between them is both both are non-contact force. Both are non-contact, and they are conservative forces. Conservative. In non-contact, sorry, In non-contact, we have also like forces of the magnetic, magnetic force, nuclear force. These are the types of some forces which comes in non-contact, and the the work done is also independent of path. Work done is independent of path, and it is in if it is in closed path. If work done, if if work done in is in a closed path, then it is zero. So here we have discussed this few points about the universal law of gravitation, and this is the value of G and SI unit. Both is electrostatic is coulomb, and in case of gravitational, it is the Newton meter square per kg. And with both, these are the non-contact force, and these are called as conservative. Work done is independent of path, and work done if it is there in closed path, then it will be zero. So now we will discuss some the other law, that is the Kepler's law. In Kepler's law, what we find sometimes one questions regarding Kepler's law. The all law will be there, and distinguish the different one. इसमें planetary laws, Kepler's planetary laws. In this case, Kepler's first law, what? Oh, the Kepler's law of first law. First law, what states? It states that planets moves planets move in elliptical orbit with the sun as a focus, like this. It's a kind of elliptical shape, ellipse, we call it as. And like if sun is there, sun is here. This is sun. What second law states? In second law, we call it as a law of area. Law of area. In this law of area, the planets, the line joining the planet, and and sweeps out equal area in equal interval time. Equal area and equal. Like in this case, if it is the planet, like this is elliptical planet. Here, if it is sun, like this. If the planet is moving from here to here in this period, so this area will be equal to in within time. This is a time format. Time will be equal to like if it is moving from here to here. This will be equal like this. Area ये equal होगा within the given framework of time. So in third law or third law states law of time period. It's called it as a third law. We call it as a law of time period. Law of time period. The second was we were calling law of area. Law of time period. In this case, the q the time square is directly proportional to r square, radius square. So in planets we find Mercury. It is the nearest one. Mercury takes almost 80 days. Mercury takes 88 days for one revolution. And the furthest one it is Neptune. Neptune takes 165 years. Takes 156 years for one revolution. It is the furthest one. Now we will study the difference between difference between मास जो कि हम थोड़ा बहुत जानते भी हैं इसके बारे about it, but it is not that much important. What is mass and this? In this case, we call it as a mass as an inertia. First law of force, Newton's first law of force. It is always there constant. It is always constant of any body. But in case of weight, it is the weight. Weight is the force exert. क्या हो रहा है? force exerted by any planetary body like this, let weight equal to in our earth, that is the force by which it attract a mass. Earth attracts a mass. In this case, it is like mass into acceleration. So the mass is constant here, is a constant, and this is we call it as a gravity. The SI unit of weight is weight की SI unit क्या होगी? That is Newton. That is force equal to force. In case of mass, the SI unit is SI unit is kg. So we need to remember this one. So in this case, we study like variation in gravity, like variation in gravity. In this case, we find that gravity is more in poles than the equator, because the distance is less in from equator to gravity. It is less by 75 kilometers between pole and equator. In second case, the gravity decrease with altitude. What we find that gravity decrease with altitude. With altitude, gravity of gravity in moon is 1/6 of Earth. We have discussed now the thrust, the another force we studied like thrust. Thrust, what is thrust? It is applied perpendicular force. Applied perpendicular force. It is a vector quantity. Vector SI unit is like force, same like force in Newton. The fluid force which we receive, that is called pressure in fluids. Pressure in fluids like this, that is called as buoyant force. we call it buoyant force. Means it is an upward force which given by the liquid to the object. Buoyant force. Now we will discuss the pressure. What is pressure quantity? In pressure, it is a scalar quantity. It's a scalar quantity, not a, but it is a force upon mass, but it is a scalar quantity. Pressure is equal to always thrust upon area. So the P equal to kg m on h square m square. That is equal to m square. You can write it also as kg meter square or n m square. You can write like this also. Okay. 1 atm pressure is equal to in our atmosphere pressure. 1 atmosphere pressure is equal to 10 raised to 5 Pascal. 5 Pascal. Is SI unit is of pressure is called Pascal. In this case, we will discuss some pressure phenomena by which we come to know that is called as the Archimedes principle. Archimedes principle. In Archimedes principle, what we observe in Archimedes principle, the the buoyant force, the buoyant, the buoyant force is equal to the weight the weight of the displaced water. In this case, like if this is the container, if this much is water, like if we draw some drop out the one cubic of iron like this, if you go inside, the amount of water is displaced from here is equal to the buoyant force is given by the water. It's always equal to the buoyant force given by the water. What is relative density? Relative density. Relative density is the density of the substance taking it with the water. Density of a substance upon density of water. Density of water. Water at what temperature it should always at the at 4 degrees Celsius. At 4 degrees Celsius. Because at this 4 degrees Celsius, water do not show its abnormal behavior. It shows its present behavior. What is the correct behavior of the water? And in case water density is equal to mass upon volume. We know it. And the SI unit of density is know that is mass is equal to kg होता है and volume is equal to meters cube. So this will be SI unit of density. Now we will going to discuss another topic, that is energy, work energy. Work energy. What is work? Force cause a dis- displacement. So work is equal to, what is work is equal to? It is equal to force into displacement. So in this case, the this will be Fs cos theta. We write it as, and SI unit will be in this case is equal to Newton meter, because this force is Newton, is displacement is in meter, Newton meter, or sometimes it is called also or joule. We write it as joule. It's also energy only. That is James per square. It is a scalar quantity. It is a scalar quantity. How it is a scalar quantity. So 1 joule is equal to 1 Newton of force into displaced by 1 meter. Or it can be write it as, we can write it as a 1 joule is equal to 1/2 Newton force, half Newton and 2 times of meter. So this can be also a 1 joule only force. Work is of three types. So what are the types of work? That can be a negative, a positive, or zero. Work can be positive, it can be negative or zero. So in case of positive, the force and displacements appel are in same direction. The force and displacement are in same direction. Same direction. In case of negative, the force displacement are in anti direction. Force and displacement in anti direction. In this case, the angle between force and displacement is 90 degree. Then it will be zero work done. Because when we push a table at 90 degree, it do not move. And or pushing a wall at 90 degree or something which make the perpendicular angle, it usually do not move. When we push with a acute angle, at that time we can able to move the table. In case of energy, what is energy? What we call it as energy? Energy is we call it as capacity of doing work. That we call it as capacity of doing work. Capacity of doing work. Capacity of doing work. And the SI unit will be same because it's a work done only, na? SI unit will be joule. Uh, Form of energy, there are different type of energy like kinetic energy. We will study about kinetic energy. Kinetic energy. Kinetic energy means when we give force to any body and it comes into the moving form, it shows the motion. Then we call it as kinetic energy. The then formula of kinetic energy, what is usually, it's like 1 by 2 mass into x, mass into velocity square. So this is comes when it comes in motion. When we apply force and it shows the motion, we call it as a kinetic energy. Now we will discuss the important concept in this kinetic energy. That is, we discuss usually relation between relation between kinetic and momentum. In this case, we know that kinetic energy is equal to 1 by 2 mb square. Then, if we and in case of momentum, it is mv. So, if we try to change this in this format, in momentum format, then we have to divide the 2m in this format. Like we can write it as of 1 by 2. We will first multiply m above, then it will be m square and not b square, b only as it is. And when we multiply above, then we have to divide also by m. So uh, this is the same. If we divide, then we have to multiply also. So this can be write it as 1 by 2 is a constant which will come, and the m square v square we can write mb square, our whole, and this is m. So the mb is equal to p. So this p m b that is p square upon 2 2m. And in this case, the kinetic energy will be look like this: p square upon 2m. So when we do it in conversion form, so we can write it as 2m into kinetic energy and momentum equal to under root. It will change into under root. Okay. So this is the important formula we should remember. It comes directly in exams for the changing the relation between momentum and kinetic energy. That is, momentum is equal to under root 2m kinetic energy. So another energy is the potential energy. That is potential energy. What is potential energy? The energy stored in a object. We call it as a potential energy. The energy stored uh, in an object due to its position. Was whatever position it is, it will define its actual potential energy. Like in this case, we have many kind of energy like gravitational potential energy, gravitational potential energy, and this is the something which is there on the height. Like it's take an example like dam. In dam case, the potential energy of this dam from the base, it's like the height is h, and when we write it as mass, something is there here. Then when water is falls from dam to the lower surface, the energy is reflects and it converts in kinetic energy. So the mgh that come changes into kinetic energy, but the total energy is always, the total energy is always, when it changes into the, when it changes into when it changes into the potential energy into kinetic, but the energy is always the same. So the total energy will be kinetic energy plus potential energy. We will discuss some changes of the energy, how we change in energy from one form to another form, and the law of conservation of energy is always the first we will discuss law of conservation energy. What law of conservation energy states? Law of conservation of energy. It's always like neither we created nor we destroy. Because in every planet and anything, whatever in we can take it example like our planet. We find that the whatever that comes from the earth, it always go down to the at last it go down to the earth only. Take it from the human beings, whatever we produce, and the human beings that comes, they mix to the earth soil, that is a carbon format. So this is called as a energy is no, neither we created nor we destroy. So we can in this case the changes of energy we discuss two three the equipments which we are take using in our day to day life, like dynamo, which is the equipment which converts mechanical energy into electrical energy. It's a very important because generator works on this principle. Also, generator is for the generator it is same. Dynamo and generator are the same principal component. Generator is also convert mechanical energy into electrical energy. And motor, we find motor that it converts electric energy into mechanical energy. It helps to move something, like many plants are usually run on this, like a staircase in railway stations that motors converts electric into mechanical, like micro. Another is component is microphone. Microphone, what does it do? It converts sound energy that we find in our mobile phones, which convert into electric energy. That is also called as signals, by which we able to communicate from one place to another place. Another one is loudspeakers. Loudspeakers, what does they do? They convert electrical energy into sound energy. So these are the few equipments of the conversion of energies from one to another. We should remember all those things. It's a very easy one. Now we will do discuss about the rate of doing work, that we call it as a power. What is power? That is rate of doing work. So we discussed power. It's called it as rate of doing work. We can write it as a work upon time taken. In particular time, whatever work we are doing, that we defines its efficiency also, and we call it as its power also. It is SI unit of work is joule and time is second. So its SI unit will be SI unit of power will be joule per second, and we can also write it as watt. That's what it has been given by the a scientist James Watt. On his name, this energy is given. This SI unit is given. So in the power is also a scalar quantity, not a like work is a scalar quantity. Same like power is a scalar quantity. In this case, we will discuss the in same like rate of changing of rate of means something it changes with respect to time. Like we study that like rate of change of velocity. We call it as a rate of change of velocity. We call it as a mm, acceleration. What we call it rate of change of velocity. What we call it is like this. We represent acceleration. Rate of change of momentum. We call it a second law of motion or of force. Rate of change of. So these are the things which whenever we do rate of change of means with respect to time. In this power, the 1 horsepower is equal to, we should remember, 746 watt, and 1 kilowatt is equal to 1000 watt. Friends, we are going to discuss our another topic of physics, that is sound. It is sound. What is sound? It's a form of energy. It's only form of energy. We call it a form of energy. How this produce sound? How this produce? Actually, whenever we are there and we communicate with each other, the vibrating particles helps them to move from one place to another place. So the sound travels by vibration, by vibration of particles. There are two types of vibration. So this in vibration of particles, it is the travel bandwidth travel with the waveform. So this we call it as a longitudinal. And second one is call it as a transverse transverse wave. In longitudinal, what we observe, when the particles they move from, like these are the particles, then like this. So this we call it as a rarefaction and compression. Compression means where the particle density is more. We call it as a compression. And this we call it as a rarefaction where the particle density is less. So how does it works? It works like when the particles get an energy, then they hit the another particles present in the surrounding, and those particles when they hit they just deflect it out in that surrounding, and when they reduce their energy, then before that they hit the another particles. When they get charged, then they deflected again. Like this they work. So in this case, these particles moves from one to another, and they comes back to their position. So this is called as longitudinal waves, and by which the sound travels. In case of transverse is a waveform. It travels, the particles travels in waveform like this. So in this waveform, the particles move from here and they comes down, then they usually go there. So the upper is called as a crest, and lower part is called top. This we call it as a one wave. What we call it as a, it is called a wavelength. This is represented by lambda. The few concept of the sound waves like frequency, few terms like frequency that we represent like mu, called mu. It's equal to one upon time, one upon time. The unit is second inverse. Also, it is hertz. Hertz. It's given by the after the name of scientist Hertz. What frequency does do? It determines pitch of a sound and the amplitude determines loudness. What amplitude determines loudness of a sound. Because इतना जितना ये मूव करेगा, this is called amplitude. जितना ज्यादा मूव करेगा उतना ज्यादा loud होगा. So the unit we measure it is whenever there is in cricket stadium that we measure it in कोई कोई प्लेयर कोई सिक्स मारता कुछ मारता है at that time what we the unit is measured in decibel, that is we call it as a dv format, so it is decibel. The maximum displacement done by the particle from this to this, that is the loud, it determines its loudness. Like this in this format we can see this sound is their frequency is same but the loudness is different in both the sound. The frequency is same but loudness is different. In case of frequency, we can take it as a like this is the sound. The frequency, the amplitude is same, but in case of another one, the frequency is more in given time period. Now another quality of sound that is we call it timbre. It's a quality of sound. We call it a quality of sound. Quality of sound. What we call it a quality of sound. But in case of note, what is note? Note is a sound which is a mixture of several frequency. What we call it note? Sound which is a mixture of several frequency. Mosquito, Frequency is more, pitch is also more. Line amplitude is more. Loudness more. In this case, the audible range. What is audible range? It's a 20 hertz to 20,000 hertz for human beings. And less than this, we call it as a less than less than this frequency. Less than this, we call infrasonic sound. That is infrasonic sound. More than this, we call it as ultrasound. More than this, ultrasound. Like produced by infrasonic, like rhinoceros, elephant, pigeon. They produce infrasonic. Ultrasonic, like produced by the dolphin, whale, like this. Yeah. In Air Force, we usually discuss. We usually listen the Mach. That is speed in usually measures in Mach. So what is Mach? The plane's speed is usually measured in Mach. Mach number. So what is Mach number? It is usually actually the speed of any body upon speed of sound in that medium. Like in case of supersonic, that subsonic comes. Subsonic. Subsonic Mach is equal to less than one. The ratio should be less than one. It means the it is called subsonic. In case of supersonic, it's the Mach number is greater than one and less than two, less than five. In hypersonic, what is hypersonic? Hypersonic, the Mach number is always greater than five. It's a greater than five. Another type is that we one there is that is called transonic. Transonic, in case of transonic, the Mach speed is equal to 0.8 to 12. The speed of sounds we will different study in different material like the speed of sound, speed of sound. In case of solid, it's more. When liquid is less than gas. So the speed of light is equal to it's a 3 into 10 raised to power 8 meter per second. So this speed of light is more. It's more than speed of sound. Now we learn about reflection of sound. Reflection of sound. That we call it as a echo. What we call it as a we call it as a echo. It comes after a period of time, like if there is any source and this is the reflector, means this is the thing, the body, this is the body, any object. So this will comes back. In this it reflects like this. Based on this, we use the sonar, sonar. By this principle, it helps in navigation, navigation of submarine. We discuss some uses of ultrasound waves. What are the ultrasound waves applications? Penetrating power is high, very high. It's usually produced by cats, dolphin. Also, it was used for the gender determination, but it is banned. we can use for growth of the, and now we use for growth of determine growth of fetus. Also to identify condition of, check the condition of internal organs. The chapter we will today we have discussed about three topics. Next we will discuss in further classes. So like this we will revise all these syllabus for FCAT. The next chapter we will going to discuss, that is light. That is light or lens. Lenses, which lenses will come, reflection of light, eyes of sight. So here we are going to end this session. Jai Hind, Jai Bharat.